My dear students, welcome back to our channel. Students, in this video I am explaining MBA 3rd semester, Subject Operations Management, OM, 4th unit important short and long questions and answers. Let's start quick revision. First important long question is productivity. Importance. Productivity is the measure of how effectively we use our time and resources to achieve desired outcomes. It plays a critical role in both personal and professional life, shaping success, growth, and overall satisfaction. At its core, productivity is about getting the most value out of our efforts, working smarter rather than harder. In the workplace, productivity is often linked to efficiency, where employees complete tasks with minimal wasted time or effort. This directly affects a company's profitability, growth, and competitiveness. For example, if a marketing team increases its productivity by using better tools for content creation and scheduling, they can produce more campaigns in less time, thus increasing their impact and return on investment. On a personal level, productivity allows individuals to achieve their goals, whether in their career, health, or personal development. Consider someone who wants to improve their fitness. Instead of spending hours at the gym without a clear plan, they might use a structured training program and track progress. This focused approach leads to better results in less time, illustrating that productivity is not about working non-stop but rather about working efficiently toward set goals. Effective productivity requires prioritization, time management, and focus. One common method is the Pomodoro technique, where you break work into intervals, typically 25 minutes, followed by a short break. This helps maintain focus and reduces burnout, making it easier to sustain high levels of productivity over time. In conclusion, productivity is vital in all areas of life because it enables us to use our time and resources wisely. Whether achieving career success, advancing in personal development, or simply managing daily tasks, enhancing productivity leads to more meaningful results and a better quality of life. Next important long question is measurement of productivity. Measuring productivity involves evaluating how effectively resources, such as time, effort, and materials, are used to produce goods or achieve outcomes. It is a crucial step in understanding performance and identifying areas for improvement, both in organizations and individual efforts. There are different ways to measure productivity depending on the context, but the general formula remains the same: output divided by input. In a business context, one common method of measuring productivity is labor productivity, which is calculated by dividing the total output, such as revenue or units produced, by the total number of labor hours worked. For example, if a factory produces 1,000 units in a 40-hour work week, the labor productivity is 25 units per hour. By tracking this over time, the company can assess whether production is increasing, decreasing, or staying the same. Another way to measure productivity is total factor productivity, TFP, which takes into account multiple inputs like labor, capital, and materials. This metric provides a more comprehensive view of how efficiently all resources are being used. For instance, a company might invest in new technology that allows workers to complete tasks faster with fewer errors, resulting in increased TFP. In personal productivity, people often measure output in terms of tasks completed or goals achieved over a specific period. For example, someone might track the number of reports written or calls made in a day. Another way is through more qualitative assessments, such as how focused and efficient they felt during their work, which can be evaluated using time tracking tools or productivity apps. To measure productivity effectively, setting clear benchmarks and objectives is crucial. In the case of a salesperson, productivity could be assessed by the number of sales calls made or deals closed within a set period. By regularly reviewing these metrics, individuals and organizations can determine how well they're meeting their goals and identify ways to improve performance. In conclusion, productivity measurement allows for better resource allocation and helps in identifying areas for improvement. Whether in a workplace or personal context, using clear, consistent metrics enables better decision-making and continuous growth. Next important long question is tools to increase productivity. There are several tools available that can help increase productivity by optimizing time, reducing distractions, and improving efficiency. Whether in a professional or personal setting, the right tools can make a significant difference in how effectively we manage tasks and achieve goals. One popular tool is task management software, such as Trello or Asana. These platforms allow users to break down projects into manageable tasks, set deadlines, and collaborate with teams. For example, a marketing team can use Trello to organize their content calendar, assign specific tasks to team members, and track progress in real time. This ensures that everyone is on the same page and deadlines are met without any missed steps. Another helpful tool is time management apps like Rescue Time or Toggle. These apps track how time is spent on various activities, giving users insights into where they can improve. For instance, if someone notices they are spending too much time on social media during work hours, they can adjust their habits accordingly. Time tracking apps also help create a sense of accountability, which can boost focus and efficiency. To reduce distractions, tools like Focus at Will or the Pomodoro timer can be incredibly useful. The Pomodoro technique involves working in focused intervals, typically 25 minutes, followed by a short break. The Pomodoro Timer app helps users stick to this method, promoting sustained concentration and reducing burnout. Similarly, Focus at Will provides productivity-boosting music that is scientifically designed to enhance focus and concentration. For more comprehensive work automation, Zapier is a great tool. It allows users to automate repetitive tasks by connecting various apps and services. For example, you can set up a workflow that automatically saves email attachments from Gmail to Google Drive and notifies you via Slack when it's done. This eliminates manual tasks, saving time and reducing the likelihood of errors. In conclusion, productivity tools are essential for managing time, organizing tasks, and minimizing distractions. By using the right combination of tools, individuals and teams can work more efficiently, accomplish more in less time, and ultimately achieve better results. Next important long question is factors affecting industrial productivity. Industrial productivity refers to the efficiency with which industries convert inputs, like labor, capital, and raw materials, into outputs, such as goods and services. Several factors affect industrial productivity, influencing the overall performance and competitiveness of industries. 1. Technology and innovation. Advances in technology play a significant role in improving industrial productivity. Automation, robotics, and computer-aided design (CAD) systems allow for faster production, higher accuracy, and fewer errors. For example, the automotive industry's use of robotic assembly lines has drastically increased output and reduced production costs. Companies that invest in modern technology typically experience higher productivity compared to those relying on outdated machinery. 2. Skilled workforce. A well-trained, skilled workforce is crucial to boosting industrial productivity. Employees who are knowledgeable and efficient can operate machinery effectively, troubleshoot issues quickly, and implement best practices. For example, in the pharmaceutical industry, highly skilled workers are essential in maintaining stringent production standards and ensuring the quality of the final product, leading to higher productivity and fewer production delays. 3. Management and organization. Effective management practices, such as proper planning, resource allocation, and workflow organization, are vital for maintaining high productivity levels. A well-organized factory with clear communication channels and streamlined processes can eliminate unnecessary delays. For example, Toyota's lean manufacturing system focuses on eliminating waste, improving efficiency, and increasing overall productivity. 4. Raw materials and supply chain efficiency. The availability and quality of raw materials directly affect industrial productivity. A disruption in the supply chain, such as delays or quality issues with suppliers, can lead to production halts or inefficiencies. Industries that maintain strong relationships with suppliers and invest in robust logistics systems, like Amazon's efficient inventory management, can ensure smooth production and minimize downtime. 5. External factors, economic conditions, government policies, and labor laws also influence industrial productivity. Economic recessions may reduce consumer demand, which can lead to lower productivity as factories scale back operations. On the other hand, government incentives for modernization or tax breaks for capital investment can encourage industries to boost productivity. In conclusion, industrial productivity is shaped by a combination of technological advancements, skilled labor, effective management, efficient raw material use, and external factors. Industries that focus on improving these areas are better equipped to enhance productivity and remain competitive in the global market. Next important long question is ISO Standards Basics. ISO, International Organization for Standardization. Standards are globally recognized guidelines designed to ensure quality, safety, and efficiency across industries. These standards cover a broad range of areas, from environmental practices to product safety and information management. Adhering to ISO standards helps organizations improve their operations, meet customer expectations, and gain a competitive edge in the marketplace. One of the most well-known ISO standards is ISO 9001, which focuses on quality management. It provides a framework for organizations to ensure that their products and services meet customer requirements and regulatory standards. For example, a manufacturing company certified with ISO 9001 would implement systematic processes for quality control, ensuring that every product that leaves the factory meets specific standards, thereby minimizing defects and increasing customer satisfaction. Another important standard is ISO 14001, which deals with environmental management. It helps organizations reduce their environmental footprint by providing guidelines on how to monitor and manage environmental impact, such as waste and emissions. A company that adopts ISO 14001 might implement recycling programs, reduce energy consumption, or switch to sustainable raw materials, thereby enhancing its environmental performance. In addition to quality and environmental management, ISO also covers areas like ISO 27001, which focuses on information security. This standard provides a framework for organizations to protect sensitive information from threats such as cyber attacks or data breaches. For example, a bank following ISO 27001 would implement strong encryption protocols, regular security audits, and staff training to safeguard customers' financial data. The key benefits of adopting ISO standards include improved operational efficiency, better customer trust, and reduced risks. Certification often leads to international recognition, making it easier for businesses to enter new markets and gain credibility. In conclusion, ISO standards provide organizations with a structured approach to improving quality, safety, and sustainability. By adhering to these standards, companies can not only ensure compliance but also enhance their overall performance and reputation in the global marketplace. Next important long question is difference between breakdown maintenance and preventive maintenance. Breakdown maintenance and preventive maintenance are two distinct approaches to maintaining machinery and equipment, each with its own set of advantages and challenges. Breakdown maintenance refers to the practice of repairing equipment only after it has failed. This approach is reactive, meaning maintenance is performed when a failure occurs, often resulting in downtime and unplanned interruptions to production. It is typically used for equipment that is not mission-critical or when the cost of preventive maintenance outweighs the potential risk of failure. For example, in a factory setting, if a conveyor belt stops working because of a motor failure, the maintenance team would carry out repairs to get the equipment back up and running. While this may seem cost-effective initially, frequent breakdowns can lead to extended downtime, higher repair costs, and decreased productivity. Preventive maintenance, on the other hand, involves regularly scheduled inspections, servicing, and repairs to prevent equipment failures before they happen. This proactive approach aims to extend the lifespan of machinery, improve reliability, and reduce unplanned downtime. Preventive maintenance is based on manufacturers' recommendations, industry best practices, and historical performance data. For instance, a company might schedule monthly inspections of its HVAC system, including cleaning filters, checking refrigerant levels, and testing components to ensure everything operates smoothly. By addressing potential issues early, preventive maintenance can reduce the risk of major breakdowns, improve efficiency, and ultimately lower long-term costs. Key differences: 1. Approach: breakdown maintenance is reactive, while preventive maintenance is proactive. 2. Cost: breakdown maintenance may initially seem cheaper, but it can result in higher repair costs and downtime. Preventive maintenance requires a consistent investment but reduces long-term operational costs. 3. Downtime: breakdown maintenance typically leads to more unplanned downtime, while preventive maintenance minimizes disruptions by keeping equipment in good condition. In conclusion, while breakdown maintenance may be suitable for non-critical equipment, preventive maintenance offers better long-term benefits by ensuring reliability, reducing downtime, and prolonging the lifespan of machinery. By balancing both approaches, organizations can optimize their maintenance strategies and improve overall productivity. Next important long question is the following data are found during the inspection of the first 15 samples of size 100 each from a lot of two-wheelers manufactured by an automobile company. Draw the chart for fraction defective, P, and comment on the state of control. To draw the P chart, fraction defective chart, we need to calculate the fraction defective for each sample and then plot those values on the chart. The P chart monitors the proportion of defective items in a sample and helps in identifying whether a process is in control or not. Here's how to calculate the fraction defective for each sample. Step 1. Calculate the fraction defective, P, for each sample. For each sample, the fraction defective is calculated as data for sample defectives and calculations. Step 2. Calculate the average fraction defective, P. The average fraction defective is the mean of the p-values across all samples. Step 3. Calculate control limits for the P chart. For the P chart, the control limits are calculated using the following formulas. UCL and LCL calculations. Since the LCL cannot be negative in practical terms, we set it to 0. So, the control limits are: Step 4. Plot the P-chart. On the P-chart, plot each sample's fraction defective on the y-axis, ranging from 0 to about 0.12, and label the sample numbers on the x-axis. Mark the following lines. Step 5. Interpret the P-chart. By reviewing the plot, if the points lie within the control limits, UCL and LCL, the process is considered to be in control. If any points fall outside the control limits, it suggests that the process is out of control and requires investigation. Sample chart interpretation. From the data, sample 12 has a fraction defective of 0.15, which is above the UCL of 0.1151. This suggests that the process was likely out of control during that sample, and corrective action may be needed. Most of the other sample points lie within the control limits, indicating that the process is generally in control, except for that one outlier. Conclusion: the P-chart shows that, aside from one outlier, sample 12, the process is in control, with the fraction defective remaining within the control limits for most of the samples. The spike in sample 12 suggests a possible issue that needs to be addressed to maintain consistent quality. Next important long question is: you are given below the values of sample mean and the range for 10 samples of size 5 each. Draw mean chart and comment on the state of control of the process. Given the following control chart constraint for n is equal to 10, A2 is equal to 0.58, D3 is equal to 0 and D4 is equal to 2.115, to draw a mean x chart and assess the control state of the process, we will calculate the control limits for the mean chart, x-bar chart, and analyze the given data. The mean chart monitors the central tendency, average, of the process and helps in identifying whether the process is in control or not. Step 1. Given data: you are given the following data for 10 samples of size 5 each. Step 2. Calculate the average of the means, x. The average of the sample means is calculated by taking the sum of all sample means and dividing by the total number of samples. Step 3. Calculate the average range, R. The average range is calculated by taking the sum of all ranges and dividing by the total number of samples. Step 4. Control limits for the mean chart, x-bar chart. To calculate the control limits for the mean chart, we use the following formulas. Let's calculate the UCL and LCL. So, the control limits for the x-bar chart are: UCL is equal to 47.564, LCL is equal to 40.836. Step 5. Plot the mean chart, x-bar chart. Now, plot the mean chart with the following information. The x-axis represents the sample number, 1 to 10. The y-axis represents the mean, x. Step 6. Interpret the control chart. Now, examine the plotted points in relation to the control limits. Conclusion: samples 2, 3, 6, and 7 are outside the control limits, suggesting that the process is out of control during those points. The x-bar chart indicates that, while most of the samples are within control limits, there are a few that are out of control. This suggests that there may be some variations or issues in the process that need to be investigated to bring it back under control. Students, for other units explanation and other subjects quick revision or explanation links are available in description. Check out once. I think it will be useful to you. Thank you. Thank you for watching. Like and share this video with your friends.